and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today I'm pleased to welcome Chris Jackson. Chris is the Chief Operating Officer for SARAS, the Center for the Safety and Reliability of Autonomous Systems in Los Angeles, California, and he's also the Acting Director of the Center of Reliability and Resilience Engineering at the B. John Garrick Institute of Risk Sciences at UCLA. Chris is the director at Acuitas Reliability in Canberra, Australia, which provides technical consulting in reliability, availability, and maintainability. Chris has a PhD in reliability engineering from the University of Maryland in College Park. Chris, welcome, and thanks for joining us.
Thank you. It's my pleasure, Tim.
Chris, can you tell us a bit more about SARAS? What role does this group play in helping to ensure safety and reliability of autonomous systems?
Well, firstly, the role that SARAS plays is embryonic. It's a relatively new organisation, and we have high hopes for it, and we're trying to establish a presence in what we think is an area which needs to be better studied, and better studied very, very quickly. So with autonomous systems, there's a lot of focus on the technology, as there should be, but there's probably more of a concern in terms from the public's perspective about how these things, when they start infiltrating daily life, will do so in a safe way. And it's a challenge that manufacturers and government agencies and regulatory bodies are still struggling with. It's a very new type of technology which we just don't have any experience in dealing with in terms of making sure it's reliable and safe.
Yeah, we're seeing a lot of proliferation, Chris, of different kinds of autonomous systems. I think most of our listeners are probably aware of self-driving cars. They may have even heard of self-driving trucks or other vehicles, but perhaps you can confirm for us the kind of growth rate that we're seeing in these kinds of systems.
Well, everyone's aware of self-driving cars because that's where the highest growth rate is in terms of, I suppose, resources invested, public perception, and I suppose the way the public views how these things could possibly change lives. We're currently seeing autonomous systems deployed in maritime industries, being developed for maritime industries, where we can better or more efficiently freight material from one side of the planet to the other. But that's an example of something that's not in the forefront of the public's perception of where the technology is heading, and that's to an extent fair enough. And the other thing is the public will be purchasing or at least using autonomous vehicles in the future. So there's this very, very tangible connection people make with specifically self-driving cars. But there's a lot of autonomous technology being developed for a whole range of different systems. So that's why SARAS, where one of the S's in the acronym, stands for systems and not vehicles.
Good point. Very good point. So I'm sorry, Chris, your organization is helping to, are they working with product designers to sort of help develop new kinds of systems? Is that part of the role that you're playing?
No, we're trying to, the answer is indirectly yes, but the answer is directly no. So we're not advocating for things like LiDAR or specific technological solutions that might play a role in ensuring things are safe. We see ourselves as doing something which, as far as we are aware, not a whole lot of organisations are solely focusing on, which is providing guidance to the regulated, the manufacturers, on how to create safe and reliable autonomous systems, and guidance to the regulator once they have an autonomous system in front of them. How do they assess that system is particularly safe? So we're trying to provide that sort of framework in which decisions can be made from the manufacturer's perspectives on how to design a system that is safe, and decisions from the regulatory body perspective in terms of saying, yes, that system is or is not safe, and helping define what safe actually is. So we're not inherently involved in technological development, but we are trying to help create a framework that allows decisions about these systems to be used or not used.
So, Chris, kind of on that note, these are obviously very new systems for a lot of our listeners. They may not be familiar with them. What are some of the new or unusual failure modes that designers and reliability engineers need to be aware of when they consider these kinds of autonomous systems?
Well, the failure modes, we're fairly comfortable, especially for vehicles, that we know the majority of the mechanical failure modes. We know things like fatigue and corrosion. So if we put that to one side, the new failure modes obviously revolve around the decision-making process that autonomous systems are authorized to make. So if a system makes the wrong decision, that's a new failure mode, which we don't have a lot of history in dealing with, at least in a robust framework. Everyone in reliability engineering knows about FMECAs and reliability centered maintenance, and that's good for things like your corrosion, your fatigue, cracking, dendritic growth, so on and so forth, but not for the actual decision-making process we're trying to create in these autonomous systems. And it might be a challenge to the extent that we have to change our framework completely. For example, you look at software. Software, in a way, makes decisions that we program that software package to make. And once it gets deployed, the decision-making framework we empower the software with doesn't always work. It has unintended consequences, or it's used in a scenario we didn't think was possible. And so we actually see, in everyone should be aware of this, the Microsofts and the Apples of the world continuously send out software patches. They have this fairly robust ongoing approach to detecting defects and faults. So autonomous systems will probably need to be more like a software system in terms of reliability assurance. There's no real easy way to certify a decision-making framework, but we need to have manufacturers of the future create an ecosystem of continually learning, continually updating to make these vehicles safe. And I think the reliability community needs to embrace this challenge and understand this challenge more deeply. We just cannot certify these vehicles as being safe when they leave the factory the same way we can with drivered cars, if that makes sense.
It does. It does make sense. Thanks, Chris. I agree with you. I think it's more of a software or even firmware problem with those seems to be the source of more of the risk or potential failure modes. And of course, software reliability is still a relatively new field of study. We've been looking at mechanical and electrical issues for some time, but software reliability is still something that we're learning more about.
Absolutely. And if we look at the Tesla crash that became, I suppose, seen as a first case of autonomous technology being involved in a fatality, and I know there's other debates about what levels of autonomy exist, but that was essentially where a driver on autopilot on a Tesla vehicle who was using the car whilst it was on autopilot impacted the side of a truck when it was crossing the highway. And subsequent reports from the National Highway Transportation and Safety Agency have looked into this, and there were things that became apparent, things that could have been done better. And how did Tesla deal with this? They actually issued a patch to make the prevalence of these sorts of situations decrease in the future. And that's the sort of behaviour we want to encourage manufacturers to adopt. And also that same report I just mentioned, when they did an analysis of autopilot driving, they determined that when a Tesla vehicle was being driven on autopilot in identical conditions, it was 40% less likely to be involved in a crash. So that's a sort of taste of the future of autonomous vehicles. We're fairly certain that autonomous decision making, when it replaces human decision making, will result in drastically safer systems. But it still won't be perfect, and we need to continually improve. But we can improve this from afar. Now, Tesla could not have had that particular patch process certified when the vehicle left the factory. Far from it. It's impossible.
Good point.
But So we need to change our focus to not being so, I suppose, obsessed with the build state of a system when it leaves a factory, but more focused on what happens during its operational life.
Chris, I'm really glad you brought that up. It's a little bit confusing where the reliability or what the role is of some of the different players are with these autonomous systems. You mentioned the responsibility of designers and manufacturers and reliability engineers. What is their role versus the role of the operators of these systems, or maybe even insurance companies? How do you see these different roles evolving over time?
Well, I think there's an interesting precedent being set by Volvo, where the CEO has come out and said that Volvo will be liable for all of its future autonomous vehicle crashes, and that's an interesting statement to say. And I think a lot of people were, to an extent, surprised, or perhaps think that's naive or foolish. And time will tell. But I think it goes to the point that goes to the heart of the issue, is that there will be the fault of any crash associated with an autonomous vehicle will reside with whoever we call the manufacturer, albeit that a collection of organisations working together to give us a system. But right now, instead of when we purchase a vehicle, we then have to go and purchase insurance, because we as drivers are liable for whatever happens to that vehicle, regardless of whether it's our fault as drivers or if the vehicle mechanically fails. The vehicle is if it meets federal motor vehicle safety standards, it is essentially absolves the manufacturer of that vehicle of any liability for any crashes thereafter. So it's the driver, the owner of the vehicle today, that is liable for all aspects of that vehicle's operation. But in the future, that will have to change, and that's why we see insurance companies and insurance agencies being involved in this discussion. But it's still perhaps based on the assumption that insurance agencies will be acting as a third party to the let's call it consumer of the service. That potentially might not be the case, especially if we look at the Volvo precedent. And in reality, if any of these vehicles crash, it's either a mechanical fault or a decision-making fault. If that's an autonomous vehicle, both those issues are the responsibilities and remit of the manufacturer. So this actually might seem as this might come across as a challenge, but in reality, it could be an opportunity. I've seen some commentary saying, but if all manufacturers then have to accept liability, well, this will increase the price of the service. Well, it may very well increase the price of the service, but you don't have to pay $1,000, $2,000 or $3,000 worth of insurance every year as the driver of the vehicle. So the driver will ultimately pay the liability, or be responsible for the liability of the vehicle, whether they have engaged a third-party insurance agency or pay for it in the recommended retail price from the manufacturer. But the idea is that by doing this, perhaps the liability will go down. The total liability will go down as these vehicles get safer. And even though the insurance policy from a certain perspective is built into the purchase price, everyone benefits.
Good point. Chris, it occurs to me that the operator of an autonomous vehicle may have some liability if they don't keep the firmware or software up to date. If the manufacturer has issued a patch, as you mentioned, and the user or the operator is not keeping the vehicle, up to date with the most recent software or firmware, it seems to kind of confuse the question of reliability a little bit.
Yeah, I agree. But I also think that we will see the responsibility for vehicle, let's say build state, move again away from the user of the vehicle and more towards the manufacturer. Tesla's a good example. Those vehicles have so many sensors on them. They communicate to Tesla when they need to be serviced, so on and so forth. And when they do, those parts are waiting at Tesla service centers. And these aren't autonomous vehicles, but it just shows they're electric vehicles. They got a different design paradigm. Tesla's not doesn't have a history of building internal combustion engines the way many Detroit manufacturers do. So we are seeing trends in this space where, although I think there's always going to be some responsibility for the user to keep the vehicle in a serviceable state, the vehicle will be so well connected and so well monitored that you could easily see this being the remit of the manufacturer again to make sure that the vehicle will not drive or operates in safe modes when it starts to degrade over time, or firmware is not updated, or it doesn't have the latest software downloaded, so on and so forth. So I do think that the manufacturers will be quite proactive in making sure this is part of the autonomous decision-making framework.
Right. Chris, I wonder if you could comment on the current state of federal or local regulations when it comes to these vehicles. I guess I'm especially wondering if there are specific requirements that are coming that will require a certain level of testing, or maybe a certain level of failure rates. Do you see any regulations coming either in the U.S. or some of the other markets?
Yes and no. I think there is a desire to do something, but I just don't think people know what that is. And I think we can look at the history of the current the federal motor vehicle safety standards as they stand today, because that's what governs the cars we see on the road. And these standards have worked very, very well, but there's lessons to be learned. So when vehicles first came out as a technology, let's say in the 1800s, there's a rush from regulators to deal with the perceived problems of these vehicles, and they were quite rightly concerned that these vehicles had to be safe. They were very powerful, at least comparatively powerful, for the technology of the day, and that meant that there was at least some public pressure on the lawmakers of the day to impose some sort of constraints on these manufacturers and the drivers of these vehicles to make sure they were used in a safe way. And this process resulted in a fairly humorous set of laws, which are today called the red flag laws, where, for example, in both the United Kingdom and the United States, you had to have a man carrying a red flag approximately 60 yards in front of this vehicle when it was being driven at all times. Probably
right, I remember that.
The most extensive example was in Pennsylvania, where the law was ultimately vetoed by the governor, but it passed through both houses, where it required vehicles to be disassembled if these vehicles came across livestock. And then once it was disassembled, these parts had to be individually hidden in nearby bushes. And it's easy to laugh about this today, but it's the lesson to be learned in all that is that regulators really cannot get ahead of the technology, and that's what they were trying to do. They were trying to guess how this thing would fail and the impact it would have on society. And they guessed that cattle and horses would be petrified. They guessed that in essence, these vehicles would be introducing lots of risk and danger to people outside of the vehicles. But experience started to show it's actually the people inside the vehicles that were more at risk. And so seatbelts started to become regulated. Airbags also became regulated, so on and so forth. But again, when these federal motor vehicle safety standards stipulated that these things needed to be built into the vehicles, they followed what the manufacturers had previously developed. In the case of the seatbelt, that happened over 100 years after the first patent for a seatbelt was filed. Airbags, that particular standard was invoked at least 10 years after airbags became standard on some commercial vehicles. So where I'm going with this is that we need to learn that even the very simple technology, comparatively speaking, that is the driver car that we use today, all the standards that we think keep us safe happen very reactively. We allowed the industry to develop the solutions to safety issues and concerns, and after they became commercialized, after they became standardized, standardized in terms of practice, they became standardized in terms of law. And to try and do anything different to this for autonomous vehicles is going to be very challenging. If we're trying to impose tests and regulations now before we actually use these things, we're going to replicate the situation that we saw in the late 1800s, where we have a new generation of red flag laws. Now, that doesn't mean we can't think about how these things need to be introduced safely, far from it. But that's the real conundrum. We have federal guidance which has essentially 15 broad categories which need to be addressed by manufacturers in terms of autonomous vehicle technology. And that includes things like privacy and security as well, electronic security. So the government is sort of waiting for the manufacturers to step forward and say, make the argument. The manufacturers are still a little bit confused about what that argument needs to look like, and quite rightly so. And that's where we hope that our centre, SARAS, will potentially be able to help research how the manufacturers make that argument to the federal government, and how the federal government can assess the argument that manufacturers make about their vehicles being safe. So it's a very, I suppose, confusing situation. The other problem is that right now it's the federal level that regulates the build state of the cars that we drive around today, and it's a state level which regulates the drivers. You get your driver's license from your state DMV, but as drivers, we own the decision-making process for whether we turn left or right, so on and so forth. So because this becomes part of the car itself, part of the build state of the car, from one perspective, that becomes a federal responsibility to regulate. From another perspective, that becomes a state responsibility to regulate. And that decision, or that delineation of responsibility, really needs to be better articulated. And the reality is, it needs to become a federal responsibility, because the manufacturers need certainty. They need to have the same build state for the entire continental US and not have to build different cars, or at least accommodate different state regulations when they design a new vehicle. So that conversation probably needs to be tied off and have that sort of framework better articulated. I'm not sure if that answers your question, because it's a rambling history of the problems of regulations for vehicles. But I think a lot of people are standing around admiring the problem and not doing too much about it.
Chris, this is clearly a rapidly growing area of technology. Do you have any suggestions for reliability engineers who are interested in learning more?
I think they need to understand, or I think the industry needs to research less the reliability assurance in the design process, and more about reliability assurance in the ecosystem. So when a vehicle is deployed, an autonomous vehicle is deployed, we need to actually, I would feel more comfortable driving that vehicle if I have more confidence in the ongoing support structure for that system. That is the manufacturer constantly looking for near misses, constantly looking for issues, and constantly updating the decision-making framework of that autonomous vehicle, so that once a car hits a patch of dry ice in Maine, and the manufacturer learns how the vehicle should have behaved in that situation, once they work that out, then every single car, through a software patch update or something similar, will then be able to of itself learn over time. I'd be much more comfortable in somehow assuring that ecosystem of ongoing support and ongoing improvement, more so than another manufacturer whose reliability assurance focuses on the design, your FMECAs, your failure mechanisms, and all those sorts of things that we traditionally do up front before it gets released, noting that every vehicle should go through that anyway. And I think that's a huge challenge. So I think the new generation of reliability engineers needs to focus more on assuring what can be human systems of support versus the actual physical material system itself. And that's not easy, and that's probably why we'll see reticence to do that, because it's easier to run a FMECA workshop than it is to somehow assess a system to be good or bad. But I think that's the enduring challenge, and we need to step up very soon.
Chris, this has been great. Thanks so much for joining us today.
Not a problem. It's my pleasure.
That was Chris Jackson, Chief Operating Officer at the Center for the Safety and Reliability of Autonomous Systems, or SARAS. For more information about SARAS, please check the show notes for the URL to their site. This is Tim Rogers. Thanks very much for joining us.